In this new chapter, we're going to talk about all kinds of things with polynomials. Which is a new word for you, but you've actually worked with polynomials before and you just didn't really know the word for it. So we're going to define them, and we're going to talk about adding and subtracting polynomials, which is just kind of something that you need to know before we can do more fun things with polynomials, like their applications and graphing and dealing with slope and everything. Okay. So we'll talk about just the objectives for now. So we're talking about adding and subtracting polynomials. You know how to add, you know how to subtract. But polynomial is a new word for you, so we'll talk about what that is and how we can add and subtract these things. So we're also going to talk about degrees of monomials and polynomials. We're going to talk about classifying polynomials based on their number of terms. We're going to add and subtract them, and then we're going to apply polynomials. So here's some vocab. Whoops. We've got a monomial. Do you see this word mono in there? Which comes from both the Greek and the Latin, which means one. Therefore, this is a number, a variable, or a product of a number and one or more variables. For example, this guy, this 0.5y squared, with whole number exponents. This means the exponent, this whole number exponent, this only applies to the exponent. It has to be a whole number, and a whole number is 0, 1, 2, 3, you got it. It's, just keep going and going and going. And remember, this only applies to the exponent. So monomial means 1. This is one term. So you see how each of these three examples, -5, 0.5y squared, 4x squared times y, you're not adding or subtracting anything, like in these examples below. You only have one term. Also, I guess we should talk about this word product. This means multiplication, remember? So product of a number and a variable, this is 4 times x squared times y. Okay, the degree of a monomial is the sum, so addition, of the exponents of the variables, that should be an S, okay, of the monomial. Goodness gracious. Variables. So, for example, if you just have 5, this is a monomial because it is a number. We don't see any variables here. So that means the degree is 0. There is no variable. But how about this next example? X squared. This is a monomial because it has one term, x squared. We're not adding or subtracting anything. And there is a variable. So we need to look at the exponent of this variable, which is 2. So that means the degree of this monomial is 2 because that's the exponent. And now, if we have more than one variable, then we add the exponents. We add the exponents of the variables, but not of the number, not of the constant term. So this is really 2 times x, which is really x to the first power, times y cubed. So we take the exponent of the x and the exponent of the y, so we get 1 plus 3, which is 4. So the degree of 2x times y cubed is 4. And polynomials have all kinds of applications in graphing, and this is why when we talk about degree, this is really talking about the shape of the graph. So for example, if we head over to Desmos and we type in x, we get a line, x. And since this is really the same as 1x, we have a slope up 1 over 1. And this is degree 1 because the exponent of this x term is 1. And if we have 2x, it's the same, it's still a line. So all of the polynomials of degree 1 will be a line. But how about a polynomial of degree 2? Well, this will be like x squared. Do you see how this curves? We've talked about this a little bit already. I had some things that curve for you. But what if I put like a 3 in front of it? Well, that still curves, just made it a little bit skinnier. So anything with an x squared will curve like this. So what if I like add a term to it? What if I do 2x squared like plus something? Let's say like 2. Oh, here, I'll delete these so you can still see them. This still is that same shape. It's a curve. It curves down and then curves back up. What if it's like a 2x though? Same thing. It's still a curve. And that's why talking about degrees are important, because the degree really tells you the shape of the graph. And each of these shapes does something different, which you'll learn about as we go forward. And as you move forward in your mathematics education, like as you take college prep, you learn all kinds of things. So if you have a third degree polynomial like x cubed, it looks like this. And all degree 3 polynomials will take on a shape that looks like this, which is really cool. And that's why we classify them based on degree. Because the degree tells us the shape of the graph, which we can apply shapes of graphs to all kinds of situations. For example, degree 2 polynomials, so these x squared, are used to model projectile motion. So if I throw a ball across the room, that'll follow an arc, which is like a degree 2 polynomial. So we're just going to talk about some of the basic vocab that you need so that you can go on and apply them later. And that's why we're learning this now. Okay, so we talked about monomial, we talked about degree of a monomial. Let's talk about a polynomial. So a polynomial is a monomial or a sum, so that's plus, of monomials. And this can be plus or minus. So 5x plus 2, how many terms is this? We have 1, 2, because they're separated by that addition sign. So it's a sum of 2 monomials. This is a polynomial. This polynomial here has 3 terms. And they are polynomials because each of these individual terms have positive whole number exponents. All right, let's keep going here. So binomial, here we go. Also, poly means many, so many monomial or one monomial. So binomial, the word bi is Greek and Latin again, meaning 2. So this is a polynomial with 2 terms. So we have something plus something, something minus something. So something plus or minus something. Trinomial, you know the word tri means 3. So this is a polynomial with 3 terms. So 1, x squared, 2, 3 terms. All right, now the degree of a polynomial. This is different than the degree of the monomial because you don't add them. You do not add the exponents of a polynomial. So you just take the greatest degree of the terms in a polynomial. So you just take the highest exponent. So for example, in 6x squared plus x, this x has an exponent of 1. This x has an exponent of 2. So we take this term, we say the degree of this polynomial is 2. Now this one, we take the highest exponent. So we have an exponent of 5, of 2, and this is really like x to the 0 power. This one has degree 0. So this is really degree 5 because remember, we just take the highest degree exponent and that's the degree of the whole polynomial. So finding the degree of a monomial is different than finding the degree of a polynomial. They're 2 different things. All right, now standard form. This is a special way that we can write polynomials so it's easy to gather important information about them. So standard form is a polynomial in one variable, so we're only going to have like all x's or all y's or all z's, written with the exponents of the terms decreasing from left to right. So that means we put our highest exponents on the left, and then we go down to the right. So do you see this is cubed, squared, to the first power, to the 0, 12 times x to the 0 power. And this is 3, 1, and then 0. So this is very easy to see what the degrees of each of these polynomials are now because it's just the degree of the first term. So this one is degree 3, the top one is degree 3, the bottom one is also degree 3. Okay, now leading coefficient. The leading coefficient is the coefficient, which is a number, like 1, 2, -1, half. It's a real number. It's the coefficient of the first term of a polynomial written in standard form. So for example, the leading coefficient of this polynomial is the number next to the highest degree term, which in this case is x squared. So our leading coefficient, a coefficient is a single number. is 3. The leading coefficient of this one up here, this negative x cubed plus 15x plus 3, to see how this is really just negative 1 x cubed. So the leading coefficient is the coefficient of this highest degree term, which will be negative 1. The leading coefficient of this polynomial is 2. And those also tell us special things about the graphs of these functions, and that's why it's important to know about the leading coefficient. And lastly, we'll talk about closed. I'll just give you a brief definition of what this even is. So, closed. It's just a special property of lots of different number sets. So a set of numbers is just some sort of string of numbers, and we can find patterns in them. So we say that a set of numbers is closed when an operation performed on any two numbers in the set results on a number that is also in that set. So we're going to talk about integers. You know, integer like -3, -2, -1, 0, 1, 2, 3. You get what I'm going here? Positive or negative, whole numbers. Okay. So, do you see here that the set of integers is closed under addition, subtraction, multiplication, but not division? I'm going to show you what that means. So, if it's closed under addition, that means if I take any two integers, like -3 plus 6. I'm picking random numbers here. I'll pick 3 and 6. Those are good numbers. What's -3 plus 6? Well, that's just 3. So if I add two integers, I get another integer. 3 is an integer. What if I subtract two integers? What if I do -3 minus 6? -3 minus 6 is -9. So I subtracted two integers and I got an integer. Well, okay, what if I multiply them? Sorry, that's -3 times 6. That's -18. -18 is also an integer, and this will be true if you pick any two integers. Okay, but what if we divide these? What if I take -3 divided by 6? I get -1/2. Is that an integer? No. Not an integer. And these all were. And that's all it means when it says closed under addition, subtraction, multiplication, but not division. And that's just getting some vocab with patterns of sets. Yeah, so that's all that means, is that if when you divide two integers, sometimes you'll get an integer, but sometimes you won't. But for these three, you will always get an integer. So that's pretty cool. All right, let's go. Let's talk about adding. Okay, no, we're going to talk about degrees of monomials first. Okay, so let's find the degree of each monomial. So remember, the degrees of monomials means you add the exponents of the variables. So I'll write that, add the exponents of the variables. Oh, sorry, I left my good pen at school this weekend. All right, add the exponents of the... This is rough. That's okay. Okay, you know what I'm trying to say here. Add the exponents of the variables. So, how many variables do you see in this first one? We just have one. It's just an x. So, what's the degree of, what's the degree of this term? It's just the exponent next to the x. So this is degree 2. Now b, we have two variables. This -1/2 actually doesn't affect our degree of this polynomial. So this is really x to the first power, right, class? This is x to the first times y cubed. We add these exponents. So it's 1 plus 3, which equals 4. Now this one, we add the exponents as well. So this will be x cubed, y cubed. We add these 3's to get the degree of this monomial, which is 6. All right, now d. Y'all, I don't see a variable. Do you? No, there's no variable. That means our degree is 0. If we don't have a variable, then our degree is 0. All right, and that's it for degrees of monomials. So just email me if you have any questions about this. Let's go ahead and write a polynomial in standard form, and then we're going to identify the degree and leading coefficient. So remember, standard form, we're going to write the exponents in order from highest to least. So which of these terms has a variable in it? First of all, not this -8. So actually, this -8 is going to go last. So we have an x squared and a 2x. So which one of these has a higher exponent? Well, the x squared. So our first term will be 9x squared. Now, our second highest variable exponent is just this 2x term. And don't forget that minus. So this is minus 2x. And our last term is just that -8. So now do you see how the degrees of each of these individual terms goes from highest to lowest? All right, now let's talk about, now it's in standard form, so this is easily going to tell us the degree and leading coefficient, which is all dealing with this first term. So this degree, remember this is different than a monomial. We don't add the exponents. It's just the exponent of the highest exponent term. So this one has an x squared term. That's our highest exponent, so our degree is 2. And now our leading coefficient is the coefficient, or the number, the constant, next to our highest degree term, which is 9. All right. Now, let's talk about classifying polynomials. We're going to write each of these in standard form, identify the degree, and classify them. So classify, when we say classify, we say, is this a monomial? Is it a binomial? Is it a trinomial? Or if it's more than a trinomial, then we just call it a polynomial. But actually, technically, every single one of these is a polynomial, because every monomial is a polynomial. So I'll write that. So each polynomial in standard form. So this 7a squared needs to go first because it has a variable to a higher exponent of that 3. So this in standard form is 7a squared plus 3. Now this can help us find the degree of this polynomial. So this is degree 2 because we just take the exponent value. This is degree 2. And how many terms do we have? How many terms do you see here? We have 1, 2. So this is a binomial. And if you want to be very precise, y'all, this is also a polynomial. All of these are polynomials because we have positive whole number exponents for all of these terms. Okay, how about this guy? All these, the second ones. Our highest exponent term will be this 2b to the 4th power, because b is our variable, plus, our second highest degree term will be that b squared term, and don't forget the minus with it. It's minus b squared, and our last term would be plus 6b. So the degree of a polynomial is just the degree of the first term written in standard form, which is just degree 4 for us. And this is, how many terms do we see? 1, 2, 3. So this is a trinomial. And yes, this is also technically a polynomial. All right, last one. Y'all, there's only one term. We can't rearrange it at all, so this is really already written in standard form. This is degree 5. And this is one term, so this is a monomial. And also a polynomial. All right. I'm going to go forward, and just as a recap, I'm also going to tell the leading coefficient of each term. So for this one, the leading coefficient is 12. The leading coefficient of the second one is 2. And the leading coefficient of this 3 plus 7a squared is 7. Remember, that's just the number next to is the highest degree term. Alrighty. So now let's go to adding polynomials. So the key here, combine like terms. And you might say, what is a like term? Like terms have the same, okay, that word is have. The same variable exponents. Okay. So what I mean by that is I cannot combine this 3x squared and this 4x because they don't have the same exponent, that you can't combine them. And you can plug in values for x to see why you can't combine those. So you have to find the same variable exponent terms. For example, you see we have, okay, so we're just adding these both. So we really don't need to pay much attention to these parentheses. Only when we're subtracting or multiplying do we need to use these parentheses. But okay, you see we have these x squared terms right here and right here. We can combine those. So this means, remember that if you have 3 times x squared, this means we have 3 groups of x squared. Over here we have 5 groups of x squared. So how many total groups do we have of x squared? We have 8. So we have 8 groups of x squared because we're adding them. We're adding these guys. Okay, I can maybe change colors to help you see these next ones. Okay, so now let's go to our next highest term. So let's go to this 4x term. Do you see another x term? Right here. So we have 4 groups of x plus 2 groups of x for a total of 6 groups of x. In other words, you might see that we're just adding that 4 and that 2. This is 6x. And lastly, we've got our constant terms. We have a 3, we have a 1, so it's just 3 plus 1, which is just 4. And that's how we added those 2 polynomials. Let's try this one. So we have 2a squared terms. So this is negative 5 plus 2a squared, which is going to be a negative 3a squared. All right, so those are out. We accounted for those. Now we have a plus a minus a. This is like plus 1 minus 1, so that's 0. That's 0a. So those terms actually cancel each other out. Now we have a 2 and a negative 9. So what's 2 plus negative 9? Minus 7. All right. That's how you find the sums of polynomials. You combine the like terms, and remember that like terms are the terms with the same variable exponent. So they have the same exponent attached to the variable. Alrighty, now let's go talk about subtracting polynomials. Find the difference. Okay. So the important thing here is to distribute the negative. Here, I'll go back to a color you can actually see better here. So distribute here. Distribute the negative. So I'm just going to say this, distribute the negative, which means when you see this negative sign and then a polynomial in parentheses, that means this negative sign is being applied to every single term. So I can go ahead and write this as 3y squared plus 8, and then I'm going to write this by distributing the negative to every term. So it's going to be minus 6y squared, and a minus a positive 4y, which becomes a minus 4y, and then a minus a negative 2, which becomes a positive 4. So do you see how this minus sign here just flipped the signs of each of these terms inside this polynomial? This positive 6y became a negative 6y, the positive 4y became a negative 4y, and this negative 2, became a positive 2. Excuse me. And now we combine like terms, just like we did before. So now we see we have a y squared term here and here. So we have a 3y squared minus a 6y squared. So it's really like 3 minus 6, which is negative 3, y squared. Now those terms are accounted for. And now let's look for our y terms. Okay, we only have one right here. So we just put this down here for y. And now we have an 8 and a 2. So this becomes plus 10. And we can't combine any of these terms because we have different variable exponents with all of them. So that's it. Now we're done. All right, so this next one, we're going to do the same thing. Distribute this negative to each of these terms. So this becomes 12t squared plus 5t minus 7. All right, we got a minus a negative 4t. That becomes a positive 4t squared. Plus 3t, so apply that negative. This becomes a minus 3t. And that negative 1 becomes a positive 1. All right, now let's combine like terms. So you see we have a 12t squared and a 4t squared. That becomes 16t squared. Now those terms are accounted for. Let's look at our t terms. We have a 5t and a negative 3t. So that becomes just a positive 2t because we added 5 minus 3. Now we have a negative 7 plus 1, which is minus 6. Now every term is accounted for, and we simplified. And that is how you subtract polynomials. So you distribute the negative and then combine like terms, just like you did when you added polynomials. All right, y'all, last part of this video. We're going to work with some applications here. So you drop a ball from a height of 98 feet. At the same time, your friend throws a ball upward. Polynomials represent the heights and feet of the balls after t seconds. So we're throwing this ball down. This guy's throwing this ball up. So before the balls reach the same height, write a polynomial that represents the distance between your ball and your friend's ball after t seconds. So y'all, these equations actually are not just gibberish. Do you see how these are t squared and t squared? I kind of showed you what this t squared looks like. These are curves. So they look like this. So if I throw a ball off a building, it'll follow this path of this line. These are why these are t squared. This negative 16 accounts for the gravitational force. So this negative 16 literally is just the force of gravity on this ball in feet per second per second. This 98 is our starting height. So that means this 6 down here is this person's starting height. So this guy must be 6 feet tall, at least. And you see this negative 16 is the force of gravity on this person's ball as well. They also have this middle term, which accounts for the velocity that this person is throwing their ball upward. So, yeah, and that's just what each term means. They're not just random. Okay, so, to help you maybe see this, let's, if I'm throwing a ball down at 98 feet, and we're throwing a ball, this guy's throwing a ball up starting at 6 feet, how far away do they start initially? How far away are they? Well, that's 98 minus 6, right? Which is 92. So to find the distance between these two balls at any given point, we're going to subtract these polynomials. So this is negative 16 t squared plus 98 minus negative 16 t squared plus 46t plus 6. Okay, so now we're going to distribute the negative to each term. So we get negative 16 t squared plus 98 minus a negative 16, that becomes a positive 16 t squared. Let's see, we have a plus 46t, but apply that negative, and we got a minus 46t minus 6. T minus 6. All right, now let's combine like terms. You see these t squared terms? We got a negative 16 and a positive 16t. These actually just cancel each other out. That becomes 0t. So we're left with negative 46t. 98 minus 6 is 92 plus 92. Now let's talk about what each of these terms mean. So this 92, we already figured out. Remember this 98 minus 6 was 92? This is the starting distance between the two balls. So they start 92 feet apart. This negative 46, so this leading coefficient of negative 46 is the rate of change in the distance between the balls. So, for example, you might say, okay, well, when do these balls actually hit each other? Well, experiment. What if t equals 2? When t equals 2, that means 2 seconds. What's negative 46 times 2? Plus 92? 46 times 2 is 92, y'all. So this is